So Aleksandra is Associate Professor at the Gdansk University of Technology at the Faculty of Management and Economics. She graduated at the Success University and Gdansk University of Technology. She holds a PhD from the University del Marche in Italy. And as postdoc, she stayed at the University of California, so Berkeley, at the Pompa Fabra, and also has various other research stays on her list, like the University of Roma, the Kiel Institute for the World Economy, the University of Macerata in Italy. And she's also one of our partners in the EU Horizon Rethink GSC project. And it's a pleasure to welcome her today. Her research focuses on empirics of international trade, global value chains, and technological progress, and the impact of all that on labor markets and productivity. And recently, she also, or not just recently, I think in general, she works also a lot on patent data. And today she will present on one of her papers using patent data precisely. She will present the new data set on knowledge creation and patenting by European higher education institutes. So welcome, Aleksandra. Aleksandra's talk will be followed by a discussion. First, Jürgen Janger will discuss her paper, and then the discussion is open for the audience. And before Aleksandra starts, just one clarifying question. So clarifying questions. If you have any in between, feel free to raise these. All other questions and comments, please keep them for the discussion in the end. So the floor is yours, Aleksandra.
Hello. Thank you very much, Brigitte, for this super nice introduction, and I'm very happy that I can present this work today. So yes, as just said, this presentation will focus on the work that we have developed within the Rethink GSC Horizon Europe project. The main focus of the project itself is on global supply chains and also the transfer of knowledge between countries. So this is where we contribute. So we analyze activity of European higher education institutions and patenting activity. So we want to analyze to what extent European higher education sector contributes to the creation of new knowledge, in particular the knowledge that is visible in patent data. This work and everything that I will present today is based on a joint work with my colleagues also from Gdansk University of Technology. So apart from me, Piotr Płatkowski, Sabina Szymczak, and Joanna Wolszczak-Derlacz. What I plan to show today focuses on three issues. So one is the presentation of this data set that we have created. The data set is called KCHEI. This comes from knowledge creation of higher education institutions. So the data set it's a micro level data that provides quite granular statistics on patents. So it links patent records as a main proxy of knowledge creation of multiple higher education institutions from Europe with lots of institutional characteristics. So we can analyze not only patenting activity of universities, but also find out what can influence patenting trends in higher education system in Europe. So then, based on this data, I will show you some evidence on university patenting in Europe. We believe to provide quite a new evidence. Of course, there are other studies on university patenting. Recently, we've also seen a new report by a European Patent Office. But there are some features that distinguish our approach from them, and I will talk about it in a minute. So I will show you a set of stylized facts about the time trend. So what's going on in university patenting in Europe, what's the distribution of this activity across different universities, across countries, across regions. And as you'll see in a moment, it is a highly clustered pattern. Then I will show you some of the results of the analysis that we are currently doing. So examples of application of these data sets, mainly focusing on finding out what are the main determinants of university patenting. And finally, I will formulate some policy lessons, because I think it's important to bring our data and our analysis to the sphere, yeah. So to provoke some policy implications and find out how we can contribute to the policy perspective. Okay, so looking at the background of our analysis, we refer mainly to the literature on innovation and on patenting that this literature uses patenting data as a proxy for new knowledge creation, and this is an approach that is well established in the related literature. So I'm just listing a few of the related contributions. The idea is that when something new appears, yes, we should find some indicator, yes, to what extent this innovation is really new, and patent data is wonderful for this, because it is also a very detailed data. Yeah? So it allows us to identify lots of characteristics of the innovation, and it tells us a lot of things about the creators of knowledge. And knowledge can be created, of course, by very different entities. Yes, it's often created by firms. It is also created by universities or other research institutions, and there's quite a large literature analyzing patenting activity by universities or research institutions. And finally, this can be done jointly. So firms and universities cooperate, and this is related to the so-called third mission of universities. Yeah? So apart from teaching and research, universities should provide some link to the external world. Yes, so by cooperating with firms, they have the possibility to realize this third mission. But if we have a look at the data, actually patents are quite maybe surprising, but also quite worrying, yes, in some aspects. So for instance, the recent EPO report on the university patenting documents that out of all the patents that were filed at the European Patent Office, only 8% of them come from universities and public research organizations. Most come from large companies, over 70%, 20% from small and medium-sized enterprises or some individual inventors. So the role of universities, European universities, seems to be quite small. Yeah. Then there are studies showing that this third mission is actually also quite weak, because less than 10% of all patents are filed jointly by firms and universities. And in our data set, we find out that out of the whole universe of all European higher education institutions, over 70% of them do not report a direct patenting activity at all. Maybe I should specify what is this direct patenting. So in patent data, we can see both applicants and inventors. In the patent statistics, universities can only be directly identified in the applicant data. Yes, inventors typically consist of individual people, and this, of course, creates some problems, because, of course, individual persons like professors, yes, employed at universities, they can also generate knowledge that is then patented, but this patent will not be attributed to universities. Right? So in the analysis of patenting in higher education system, there are different approaches. We can analyze these direct patents, so patents in which universities are listed among patent applicants. but also indirect patents. So by tracing, for instance, people that are inventors and looking whether they are employed or or in any ways linked to universities. So it's much more complex. In our analysis, we focus on direct patents. And looking at these direct patents, yes, as I've said, we see that most of European higher education institutions do not report such activity. When we have a look at global trends, we see that top universities, top patenting universities come from US, come from China, but not from Europe. Just 2 of them come from Europe. So this global competition is extremely strong, and Europe is not leading here, yes, in this sphere. And this is quite worrying, especially if we take into account the so-called European university paradox. This expression comes from mid-1990s when European Commission was developing strategies for innovation and also was analyzing the role of universities in generating new knowledge and in generating innovation. And this paradox refers to the fact that many European universities are perceived to be very strong in terms of research, but then when we have a look at the patent data or innovation data, it's like a mismatch, yes? So they are very active in terms of research, but not so active in terms of bringing this innovation to the market. Yes, U.S. institutions are much better, yes, in this field, and in the recent years, there's also very, very strong competition from the Chinese universities. So we are lagging behind. Yes, European universities are lagging behind in this concept. Very recently, there's been this new so-called Draghi report on European competitiveness, and the role of universities can be also analyzed in this context. Yeah, so how we can enhance European academia to bring research to the market. Yeah, so be more active, for instance, in terms of patenting. So what is the database that we've created? So as I've said, it's a micro-level database. So we analyze single universities, not only universities, because the term higher education institutions is broader. Yeah, so this encompasses, let's say, classic universities, technical universities, but also some applied schools that are also active in terms of patenting. So we take the whole set of all the higher education institutions in Europe. And this database accompanies another data set that has been generated within the Rethink project that is on global knowledge input-output flows, the so-called CAIO table, that also uses patent data, but at the level of countries and industries. Yeah, so it's a bit more general. In our data set, we have 2 samples. So one is broader in terms of the time dimension. So this encompasses European higher education sector from 1980s onwards. And here we have identified 866 patenting universities. This we call sample 1. And then we have an accompanying data set that is a bit shorter because it's just from 2011 up to 2019, but it merges the data on universities that are active in patenting system and those that do not patent at all. Yes, and we merge their characteristics of both groups of universities, and then we can compare in what in which terms they differ. Yeah, so this sample 2 will be used to identify what are the key drivers of patenting activity. So the question, an important question, yes, to be answered is also how to identify a university patent. It's not so easy because very often in patent applications we have multiple applicants. So out of all the patent applications from 1980s onwards that are visible in PATSTAT, so we are using PATSTAT database as a primary source. We analyze those patent applications that have at least one university among assignees. And this assignee has to come from Europe. Yes, we focus on Europe. So the issues that are related are the following. So one is this distinction between direct and indirect university patents. So we do not capture indirect university patenting, but only the direct activity. And then related to this, the issue of so-called professor's privilege. So some of the countries have adopted specific rules that allowed people employed in academia, like professors, to apply for a patent that was generated as a result of research done at university under their own name. Yeah? So the name of the person is among applicants and not the name of the university. Yeah? So this is also kind of a problem, yes, when identifying university patents. In order to take into account the fact that there are multiple assignees, we recalculate all the data using fractional count procedure. So, for instance, if we have a patent in which there are 4 applicants and just one is university, 1/4 of this patent would go to the university. Yes. So when counting the number of patents, for instance, across universities, we take this fractional apportionment into account. So as I've said, we identify all direct university patents in PATSTEL Global since 1980s onwards. The sample encompasses 866 patenting universities plus over 2,100 non-patenting ones. These universities come from 31 European countries, so it's quite a wide sample. We analyze both all patent applications and patents that were eventually granted. So we do not discriminate here. We take into account patents that were filed at 5 key patent offices. So these are patent offices from US, IPO, so the European one, from Japan, Korea, and China. And altogether, they are responsible, let's say, for 85% of all patent applications in the world. Yeah, so it's a vast coverage. But we also compare these statistics to patents that were applied for only in the European Patent Office or in the USPTO. Yeah, so we provide quite a wide comparison. We do not limit our dataset just to one or few indicators, but we have actually elaborated 30 alternative indicators of patent activity and patent quality, because we merge our data with some external sources like OECD dataset on the quality of patents. The quality of patents is measured mainly on the base of the patent citations. Yes, so the actual impact of patents elsewhere, yes, whether they were cited or not. And then we have more granular data that allows us to analyze patents across different technological fields. In particular, we can also identify AI patenting. This is done by identifying specific CPC codes. Yeah, so the identifiers of patents and the correspondence between CPC codes and AI domain. Looking at the sources, PATSTAT is the primary source. Citations patent quality indicators come from OECD, OECD Patent Quality Indicators database. Then when merging our institution level patent data with external sources, we use mainly ETHER dataset. This is the most comprehensive dataset on institutions in higher education sector in Europe. From ETHER, we take data on institutional characteristics of universities, so their size, financial structure, structure of students, many different indicators. And we use some additional sources in subsequent parts of the analysis. We have detailed data on location of universities, so we also merge all the statistics with the regional databases from Eurostat. So for instance, we can link patenting performance of universities with characteristics of the regions, yes, in terms of industrial structure, in terms of labor market structure, GDP per capita data, and so on. Going back to the identification of universities, yes, in PADSTAT, it turns out to be highly problematic because in theory, in PADSTAT, there is a list of applicants and also the variable that should assign applicants to specific sectors like companies or university sector. But then it is a huge mess. Okay, so anybody who has worked with micro level data for firms like Amadeus data, Orbis data would encounter exactly the same problem. The problem is that very often multiple numbers, identifiers, actually refer to one university. So we have found some really extreme cases when institutes like Federal Institute of Technology from Zurich or Trinity College from Dublin had 80 or more different number identifiers of these PSN codes and names in PADSTAT, yes, which means that we had to adopt a specific procedure to identify, yes, them as one institution. Okay. Very often there are mistakes in names. Names are super long. They are in different languages. Lots of different issues that had to be solved. So what we've done, we have created a crosswalk between identifiers of universities in PADSTAT and in Ether data. So we have created this PADSTAT Ether crosswalk that allows us to merge these multiple names, identifiers of universities in PADSTAT with identifier of universities in Ether dataset that is much more clean. Yeah? And this work on the PADSTAT Ether crosswalk involved some automatic procedures like using the similarity metrics, so the comparison of the similarity of the names in both datasets, but also lots of manual checks and additional operations. So it took us really a long time to construct this crosswalk. But once it was done, it's like a major step, yes, in the construction of the whole data set. So we were able to provide this unique correspondence between two identifiers, yes, two variables in PADSTAT and in Ether. And we have reached quite a high success rate in matching the two data sets. It's 87%. So we are quite happy with this result. So the creation of the whole data set was really super complex, yes. So in the paper, there's a whole description, yes, of the procedure from the very, very first steps, like taking the data from PADSTAT towards merging it with other external data sources, this PADSTAT Ether crosswalk, and so on. Yeah, so I'm not going to describe in detail all this graph, but just to show you, yes, that we've gone through all of this procedure, and finally we have created our database. So in the first sample that focuses only on patenting universities, patenting meaning that in the analyzed course of time, so since 1980s onwards, we have found at least one patent application, say generated or partly generated by this university. So these are universities, patenting universities in Europe. As you see, the sample is composed of universities from all over the continent, let's say. So not only EU countries, but also countries from the outside of the EU, like Switzerland. Of course, the distribution is not even across countries because in some countries, like in Germany or in the UK, we'll find lots of patenting universities, while in other countries there will be just a few of them. Some of the countries, like Sweden, will be affected by the problem of professor's privilege, so the data is likely to be underestimated, yeah, in this country. So that there's a cross-country heterogeneity. Most of the universities in this patenting sample come from Germany, 19% of them, then France and UK. In sample 2, that merges data on patenting and non-patenting universities, the time span is shorter, and this is due to the availability of data from Ether. Yes, because when analyzing characteristics of these universities, we had to rely on Ether data that is available from 2011 onwards. And here we also see the map of all these points. And so now I will show you some of the key stylized facts that emerge from the dataset. Looking at the time trends, so focusing only on the sample of universities that are active in patenting, even if they had just one patent, the number of all patent applications that were filed by European higher education institutions has been increasing. And this increase is particularly visible from mid-1990s onwards. Yeah? So this is a positive, let's say, sign. Yes. In terms of patents granted, and this is this red line that you see, we also see the rising tendency. This downward part here is due to the lag that is between patent application and patents granted. Okay, our sample finishes in 2019, so these are probably patents that have not yet been granted. Let's say, yes, they still appear as just patent applications. Yeah, so this is not something that we should be particularly worried about. Yeah, but rather we should look at the trend of all patent applications. Looking at the rankings, yes, so country rankings. So of course we can, with this data, we can construct lots of different rankings. Here you see the example of ranking according to all patent applications in the analyzed period, and then according to patents granted. Among the top countries, yes, we'll find UK, Germany, France, Switzerland, and Belgium. So not much, actually nothing is changing when we take granted patents. And this is, this means that out of these 5 top patenting countries in terms of university patenting, 2 countries are not in the EU, yes, UK and Switzerland, right? Especially the UK, yes, is a problematic issue now, yes, after Brexit. So from the perspective of the EU policy, yes, it's an important insight. You can check where Austria is located, yes, at the 11th place. Poland is right below, yes, in the 12th place in the ranking. Looking at the institution level ranking, yes, we identified top universities. Here you see 2 maps that show you top 100 European universities. These red dots, these are top universities in terms of all patent applications, and the blue ones in terms of patents granted. And unsurprisingly, most of them come from the UK, from Germany, Benelux countries, from France, and some selected locations, yeah, throughout Europe. But this is mostly Western Europe, the core of Europe. Yeah? East and Central Europe is actually inexistent, yes, among these top performers. And then we see really striking differences across universities. Yeah, so looking at this very top, Oxford, University College of London, then Swiss institutions, yes, they have generated really a lot of patents. Yeah, but again, yes, these are universities that are actually not in the EU. Yeah, so from the perspective of this European paradox, this is problematic, yes, for the EU policy.
Aleksandra?
Yes.
I don't want to interrupt, but since I know that you have quite some slides to go,
I should be quicker.
could you?
Yes.
Okay, thank you.
How much time I have left? I will go.
Actually, 5 minutes, but take bit more.
So I will just show key things.
I mean, you have some interesting applications. So
yeah. Okay. So what I want to stress also is the fact that the distribution of patents is highly skewed. Yeah. So 45% of all the universities you see that these are the top ones. Yes, they occupy almost all. Yes, the whole place. And also looking at the geographical distribution, yes, we see how concentrated this is. Yes, so this economic core of Europe, these red ones, yes, are located here. And so we have very strong core periphery structure of university patenting. And this is visible at the level of the whole Europe, but also in single countries. Yeah. So, for instance, looking at Germany example, we see these are regions with top university patenting institutions, but this is even more visible when we have a look at more granular data. So sometimes a region appears to be quite strong in university patenting, but this is actually a very, very tiny part of the region. Yeah? So the clustering of university patenting is very strong. This is typical for many countries. For Germany, here you have the example of France. We've analyzed UK, of course, Italy. Yeah. So this geographical clustering and core periphery relation is very much visible in our data set. Possible applications of the data set involve, for instance, running regressions in order to find out what determines this patent. Yeah. So recently we've analyzed differences between patenting and non-patenting universities, finding that of course those that are that have this STEM orientation patent more. One here corresponds to patenting universities. Yeah, universities that are bigger in terms of the number of students, those that are richer over here, so revenues per academic staff, those that publish more. These are also much more. These universities are also much more active in terms of patenting. Yeah, and in particular, a nice thing to analyze, and this is something that we are doing now in another paper, is to analyze the role of the funding structure. So, for instance, whether the fact of gaining more resources from third-party funding affects university patenting. So we have tried some regressions, yes, running or relating, yes, patenting activity of universities with different characteristics, institution level characteristics. And what we find is that, and these are the results, that STEM institutions, yes, of course, patent more. Those that are bigger, yes, are more active in patenting. Those where teaching load, so students per academic staff is higher, have lower patenting activity. Universities that have high publication record are better in terms of patenting. And finally, in terms of revenues, not only richer universities patent more, but also those that have bigger share of so-called third-party funding. So funding coming from contracts, from grants, from research projects. Yes, they're probably much more effective in using these funds also for patenting. Yeah, so that was just an example of a potential application of our data set. And some policy lessons, yes, that can be drawn, yes, finally. So we believe to provide a data set that allows for data-driven decision-making, yes. So if we want to analyze innovation in Europe, in particular, what drives innovation in higher education sector, we need very specific data, and we believe to provide such data. But there is a problem, yes, lots of dilemmas that are that can be formulated. For instance, whether this concentration and core periphery relations, what should we do, yes, with them? So should we focus on cohesion, yes, and let also these less performing universities to grow up, or whether we should accept this extreme concentration and say, okay, these are top ones, and they will be able to compete globally. So let's focus on them. Yeah. So it's an important policy dilemma. The problem of the third mission, yes, so collaboration between academia and industry in patenting, yes, it's another issue. And finally, research funding strategies, yes, so what we have found that this third-party funding is actually one of the drivers of patenting success. This implies that maybe more emphasis should be put on this issue. Okay, so I will stop here. Of course, I'm open to all the questions and remarks and everything. And that's all from my side. Thank you very much for your attention. If you want to get in touch, just write me an email. I will be very, very happy to answer. Thank you so much, and sorry for being too long.
No, don't worry, don't worry. It was then much shorter than I expected with the 32 slides. So thank you very much. It was really nice to see what you actually can all do with the data set. Before we start in the general discussion, Jürgen, please start your discussion. Jürgen, we can't hear you yet.
So now it should work. I've shared my screen. Can you see the slides in presentation mode?
Yes.
Yeah, okay. So yeah, thank you very much for this very interesting paper. I'll try to be brief. So the paper creates a new data set on patents that have been filed by universities. An important point, universities as organizations, for example, by university administrations or technology transfer offices, drawing on a variety of databases such as PatStat and ITER. And generally, I think the methodology is really thoroughly described and replicable. The tools, and in particular the methodology to link PatStat to ITER, is available to other researchers. That's a great effort. It's very transparent. Thank you very much for that. And in terms of results, the authors find that university patenting is heavily concentrated and that knowledge creation by European universities could be improved. Right, so I have a couple of comments on methodology. And the first one is, so patents carry information on the applicant organizations, so who will enjoy the property rights if granted, and the inventors, so the people that actually created the knowledge leading to the invention. And the data set presented only looks at the patents where universities as organizations are among the applicants, not where university researchers are inventors. And we have other papers in the literature which write about this, and they say that measuring academic patent activity is complex because actually a lot of such cases arise where university researchers as inventors are on the patent, but the university as an applicant organization is not on the patent. Only the firm is on the patent. So, and what, for example, other people such as Neuhäusler and Fritsch do is, in addition to registering the universities as applicants, they also match journal authors with patent inventors. For example, they match Scopus and PatStat. And so this issue is actually really large because, so in these other papers, they say 50% of patents by universities actually would be missed if you only focus on applicant organizations. And actually in countries as you have said, for example, in Sweden, where you have the professor's privilege, that's actually close to 100% because most of the patents there are owned by professors, not by universities. And for example, you miss the patents, for example, in industry science research collaboration programs where the firms own the patents, but university inventors are on the patents, and there's quite a few examples for this. So I think you should just acknowledge this literature and the limitations of the data set, which is of course also very important for the policy implications which you draw. And it would be interesting as well to have a comparison of your results for the institutional applications with the other papers I mentioned. So the second thing I want to mention is that the finding of high concentration may be partly linked to lumping University of Applied Sciences together. For example, you say that even among STEM institutions, only about half actually patent, and that may be because among these STEM institutions, there's a lot of universities of applied sciences, and I can see it in the Austrian data, for example. So there's quite a few organizations there, but universities of applied sciences are much less research intensive, and so they're patent much less than universities, if at all. And I think you should be able to do this actually in ITER. There is a marker for universities of applied sciences versus universities. By contrast, basic research extra-university organizations, which in some European countries are quite important and much more important than in the US, for example, they are not present in ITER and are likely to be missed altogether. There's a question mark here. I don't know if you can say something about this. For example, Max Planck Society in Germany, CNRS in France, quite important. We have a large extra-university organization, ISTA in Austria, that is also not present in ITER, for example. But in general, I think that the concentration you find is plausible, is a typical result of a distributional analysis of knowledge production. If you look at paper production, you also see that heavily skewed publication of a few top organizations, of a few top research authors. And what we also see in the literature is that top research organizations disproportionately commercialize knowledge via patents and spin-offs. Now I'll come to the interpretation of data and the policy implications, because you draw quite strong policy implications. And I just wanted to say a few things, I think, which are necessary to frame the paper. And so when you just read the paper, but also listening to your presentation, it appears that patenting is a main objective of university knowledge production, very similar to firms, actually. But so we know that there is key differences between the logics of knowledge production in firms and universities. And I think you should shortly mention that in the paper to sort of frame the analysis, and also to maybe be a bit more cautious in terms of the policy implications. And because firms, they first want to protect the knowledge they create to increase their competitive advantage. But universities or academic researchers, they want to publish the knowledge they created as quickly as possible to establish priority to earn the academic credentials. So the key codified knowledge output of universities are first papers, and patenting is just one way for universities to transfer knowledge into the economy. And there are three main ways. And the most important one is flows of people, namely graduates, and then the intersectoral mobility of researchers. And then you have formal and informal research collaboration between firms and universities, for example, and then the own commercialization of spin-offs and patenting, licensing, and so on, but it's usually only a small part of the third mission. I think this is an important framing issue for your paper and for the policy implications. And what we also know, for example, from the literature, from the empirical literature, is that top US universities are more engaged in commercialization via spin-offs and patents. And this is a consequence, among others, of the higher research intensity or the frontier research characteristics, where researchers themselves are needed in firms to be able to apply the knowledge. Whereas in Europe, especially the technological universities, show more research collaboration, so common research with firms. It's more applied research usually. And hence, the conclusion which you draw that the third mission in general is weak, I would say is not warranted from the data you present. Also because you don't have university inventors on firm patents. And so I think if you want more patents by universities or more direct commercialization by universities, next to various organizational tools and structures and legal frameworks, reforms of legal frameworks, I think the first thing you have to do is focus on the research performance and the funding, because the higher patenting activity is a clear correlate with the higher research performance. And very nice, the top universities you presented in your data set, and you typically see those are the top Swiss, British, Dutch universities which we know. And you also see in ITER data that they have about 2 to 3 times more financial resources controlling for size than your typical average EU university. And of course, it doesn't mean that money is everything. There's lots of things you can do in terms of organization, but I think you should mention that the amount of the dimension of the difference between research funding between different universities is a key factor in explaining this patenting performance. And it's less a problem of mindset, I think, because people complain about the European mindset and so on. I think it's more an issue of the research characteristics and the determinants that allow for these characteristics. And one key factor among those is the research funding, which is very, very different between top British and top Swiss universities by comparison with your average European university. Yeah, that's me done. Happy to discuss further, of course. And yeah, thank you again for the paper. As again, really a model example in terms of transparency and replicability. Thank you very much.
Thank you very much, Jürgen.
Thank you.
Aleksandra, please.
Yes, thank you so much. Yes, I can only agree with all the points that you raised. Yes, so of course, we are aware that the evidence that we are providing refers only to direct patenting. Yes, and for sure it should be much more stressed in the paper. Yes, so we will clarify this issue, and we are aware of this. You know, it was just not feasible, yes, for us to identify also these indirect patents, yes, because to do so you need to identify single people, match it with publication records, for instance, and then with location data, yes. So yes, we had lots of work just with this direct patenting. So yes, so we are just analyzing this part. Yes, concerning all the other remarks, yes, I perfectly agree. Yes, so that lots of issues. For instance, you've raised the point that there are other research institutions like Max Planck, yes, that are not in that area. Yes, of course, yes, we are dealing just with a sample of universities that are officially classified in Europe as higher education institutions. Yes. And we know that there are others that are very strongly collaborating with universities, and they do provide lots of patents, like the institutions that you have mentioned, yes. In terms of the relationship between patenting and finances, this is actually the work that we are doing now, yes. So we are using the data set to analyze in detail what drives direct university patenting in terms of finances, not only the size of all the funding sources, but also the structure. Yeah? And we see all the things that you've mentioned are very clear in the data, yes? So there's a strong correlation between patenting activity and, for instance, success in project applications, yes, at the European level. So universities that in publishing, so universities that are strong in research, visible in good publications, that are successful in EU projects, that lead EU projects, those that have lots of contracts from external, let's say, surrounding, they are the best. Yeah, so they take it all. Yeah? So this is the case of Swiss universities, British ones, some Dutch ones, and so on. Yeah. Yeah, so thank you very much. I will be very grateful if you could send me your presentation, because I will pick up some of the key things. So thank you so much for a very, very nice and helpful discussion.
Yeah, thank you very much. And now the floor is open for the general discussion. So please raise your hand for comments and questions and suggestions. Okay, so maybe let me start to break the ice here. Jürgen mentioned it already in his discussion with spin-offs and so on, also coming from universities where then patents are actually done in the spin-off and not necessarily by the universities. So this spillover is something you do not capture in the data set. How large of a problem do you think this really is?
Okay, so I think that we partly capture it because when constructing this crosswalk, we were identifying also technology transfer offices and some entities that were related to universities. Okay, so to some extent we take it into account, but of course we cannot capture the whole issue. I don't know how big this problem is. Okay, so we can only rely on estimates from other data sets, yes, like the IPO analysis, yes. So they have provided some statistics on spin-offs, yes, and how big this issue is, but they have analyzed only European patents, yes, so only patents filed at the European Patent Office. We deal with global, let's say, activity. Yeah. So their data and our data cannot be directly comparable. Yes, I think they are. They can supplement one another. Yeah, that's it. Yes, I do not have a precise answer to this question, unfortunately. Yeah, there are some country level studies, yes, that may be more insightful, yes, in these issues when people take just a subsample of, let's say, German universities or Swiss universities, yeah. But with such a big sample, yes, from the whole Europe, it's really difficult, yeah.
Yeah. So thank you. So Thomas, please.
Thank you. Now it works. Thank you. I also want to put my finger on the comment by Jürgen. Universities have a multiple set of products. On the side, you have the graduates, you have the papers, you have the patents. Probably patents are the least important for universities. At least if you look at the negotiations of Austrian universities with the ministry with regard to funding by the ministry, I think patenting does not play a lot of a role. And so I'm asking myself if you should think more in terms of economies of scope if it comes to the output of universities. So you have these 3 dimensions of outputs, publications, graduates, and patents. And probably you have something like economies of scope. So if you are good at publishing, you are very likely to be good at patenting. If you have good graduates, you may have lots of cooperations with interesting firms. And so that would that be an idea to embed all the analysis that you're doing into a production function framework where you can allow for economies of scope to operate between those 3 dimensions? Thank you.
Yes, of course, perfectly agree. So we are actually thinking of using our data set to do an analysis that takes into account these multiple inputs, multiple outputs, yes, of universities. So using the patent data as just one of the outputs, yes, along with graduates, along with publications, yeah. So to to make this analysis, let's say, fuller, yes. What I presented today, yes, of course, focuses on patents, yes, but we are aware, yes, that universities are not only patenting, and as you've said, in many cases, it's not their primary scope, yes. So yes, fully agree, yes. Thank you.